if you see that in any reaction, right, the 8 electrons has to be satisfied, right? That is called the octet, right? You will be seeing that there are many cases where the 8 electrons are not satisfied, right? Such as the 8 electrons is less than 8 electrons, right? Less than 8 electrons is actually satisfied, right? There are cases where there are more than 8 electrons are there, right, in the after bonding, right? So for those which are having less than 8 electrons, right, they are called as what? They are called as the incomplete octet. Is it clear, Mahi? Incomplete octet. Understood? Fine. Incomplete octet, such as BeCl2, right? See, so BeCl2. In BeCl2, after the bonding happened, so how many electrons are there, Mahin? Can you guide me? How many electrons are there after that bonding? There are 4 electrons, right? So it's still short of 4 electrons left, right? Now suppose BF3. BF3 mein how many electrons are there after that particular bonding? Mahin?
6.
6. So it's short of 2 electrons, right? So these can act as Lewis acids. Lewis acids are those which will be taking electrons, right? Fine.
Yeah.
They're electron pair acceptors. More than 8 electrons is called as what? More than 8 electrons is called as expanded octet. Is it clear? Right? They're called as expanded octet. An expanded octet will be there where we'll be seeing that there will be more than 4 electron domains, right? Mind understood this thing? There will be more than four electron domain. Now, if we see that when we utter the word 4 electron domains, right, or 5 electron domain, or six electron domain, right, they will be there in a particular geometry, right? So what are the geometries we are having? If we have got 5 electron domain, right, we'll be having what? We'll be having a triangular bipyramidal, right? This is also important. Pyramidal structure, right? Isn't it? Bipyramidal structure, right? Is it clear? This is a very important point we have to note, right? There will be having a triangular bipyramidal structure. And remember this thing. Mind, it's always to note down this important point. Mind, can you just guide me that if you see that particular PCl5, right? PCl5, what is the electronic configuration? Can you guide me? What's the electronic?
It has 10 electrons in around.
देखो periodic table कहाँ पे गया मेरा? Just 1 minute. Just 1 minute. I'm taking the periodic table. Okay. Periodic table. Okay. Anyways, so we are seeing what we are seeing, that if we see that it will be having 10 electrons in the outermost orbit, right? And इसका structure क्या होगा? Triangular bipyramidal. Is it clear, mind? Triangular bipyramidal. You have got chlorine, right? You have got chlorine, right? Triangular bipyramidal. Did you get this thing? Fine. Like this, right? And if you are having a lone pair of electron, mind, we understood what? The lone pair of electron should be where? The lone pair of the electron should be in axial position. Is it clear? Fine.
Yeah.
If we see a triangular bipyramidal, mind, in a triangular bipyramidal, you have to see that they will be having what? They will be having these positions, right? These positions, they are called as axial positions, isn't it? Clear? Axial positions. And these positions are called as what? These positions are called as equatorial positions. Understood, mind? Right? These are called as equatorial positions, right? So if you have got a lone pair of electron, right, the lone pair of electron will be in the axial position. Is it clear? Understood? Axial position, right? And what happens? This lone pair will be lowering this angle, right, by 2 to 3 degrees, from 120 to 117. Mind, is it clear? Got it?
Yeah.
Fine. So this is a very important point we note, right? Next thing is that if you see that when we see that the things, right, we're seeing that if it is a T-shaped, right, if it's a T-shaped, if there is 2 lone pairs of electron which is there in the 5 electron domain, right, where do we keep? We keep it in the axial position. Fine. Axial position, right? Now going to this thing, next thing is that if you see that when we see the I3, right, in the I3 minus we are having 5 electron domain and we are having 3 lone pairs of electron domain, right?
Yeah.
Okay, got it. We are having the 3 pair of electron domain, right? So that will be kept in the axial position. Mind, is it clear? Got it?
Yes.
And we are getting what? We are trying to get a linear structure. Fine. Now, next
Yeah.
important thing is that if we move to 6 electron domains, right? Electrons with 6 electron domains, right? You have to understand that whenever we are having, suppose 6 electron domain is this, right? Is it? We are having this, 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 isn't it? We're
Yeah.
having octahedral, right? Fine, octahedral. And always remember that in octahedral, always and always the central atom will be having 90 degrees angle. This angle will be 90 degrees. Can you understand this thing? This angle
Yes.
is 90 degrees, right? And we are having what? If we have a lone pair of electron, right? If we have a lone pair of electron, that will be where? That will be in the equatorial position.
Tutorial
Now
position.
understand this thing. If you're having 5 electron domain, right? That lone pair of electron should be in the axial position, isn't it? If you have got 6 electron domain, the lone pair of electron will be in the equatorial
Equatorial.
position, right? This trick you have to master, right? Fine. Mind, can you just guide me that what is the electronic configuration of particular sulfur, the outermost electronic?
4.
Outer electronic configuration. एक बार try to tell me what is the outermost electronic configuration of sulfur?
Sulfur is 6.
Sulfur is in which group? देखो, mind,
Literally
मैं आपको दिखा रहा हूँ
domain.
ऐसे. I'm teaching a shortcut, mind. देखो,
Where?
just quickly see that what is the shortcut I'm trying to teach you. Just 1 minute, mind. Just 1 minute. Give me. See, if you see that sulfur, what is the electronic general outer electronic configuration? This trick you have to know, right?
Yeah, the neat
Learn this. This is what?
electron.
This is NS2, NP, how much? NP, NP4. Is it clear? Got it? Is it clear? The outermost electronic configuration of group number 16 or 6 is what? NS2, NP4. See, 2 plus 4 gives you 6. Is it clear? Right? The outermost electronic configuration of group number 5 is how much? Tell me. NS2, NP3. Is it clear? Is it clear? Clear? What is N? N is the period number. Got it? So
Okay.
what's the electronic configuration of this particular sulfur? Sulfur is NS2NP4. What is N over here, Mahi? N is the period number. So 3s2, 3p4. Understood? Clear?
Yeah.
Got it? This is clear to you? Fine. So it's very important part we have to understand, right? Isn't it? Fine. So now going to this thing, next important thing is that if you see that when we see that the sulfur is having what? Sulfur is having 3s2, 3p4. Mine, is it clear? Understood?
Yeah. So it accepts 2.
3s2, 3p4, right? So see, I'm just teaching you how fast you can draw down the structure, right? Is it 3s2, 3p4? So 3s2, 3p4. Is it clear? Mine? Understood? Now, we know that in expanded octet, what happens? The 3D, vacant 3D will be will be giving help to form the bonding. Is it clear? Understood? Now, mind, tell me that how many bonding should be there over here? Tell me. How many bonds should be there? 1, 2, 3, 4, 5, 6.
Yeah.
So there should be how many unpaired electrons of this particular sulfur? 6. 6 electrons should be unpaired. How many electrons is unpaired now? Mind you just listen to this. It's a very important portion I'm discussing, right? It will be quickly helping you to draw down the Lewis structure.
Yeah.
Hey, how many electrons do you see is unpaired now?
2.
2. How many electrons do you need unpaired in? 6.
4 more.
6?
Yeah, so
6? Total 6?
of 4 more.
So what we do? We unpair this electron and put it over here. We unpair this electron and put it over here. Is it clear? Understood? Why the 3D is very close to the 3p, isn't it? That's the reason whenever we are having elements in after period number after period number, so from period number 3, they have got 3D close to their particular 3p. Is it clear, Mahi? Got it? Understood this part? So what happens? You might be thinking that how to put the lone pair of electron. I'm teaching you that, mind. How to is the easiest way. So you unpair this electron and you put it over here. Mine, is it clear? Fine. You get this thing? Yeah. So we're getting 1, 2, 3, 4, right? Isn't it? We're unpairing this electron and putting it over here. Is it clear? Got it? Yeah. Understood, Mahi? Did you get this thing? We unpaired this electron. Now see, now fluorine can pair up. Isn't it clear? Understood? Fine. Yeah. So what will be the hybridization? It will be SP. How many P's are there? 3 P's. 3. How many D's are there? 2 D's. Is it clear? Got it?
Oh, did okay. Yeah,
Understood?
we
This
did
is the
got.
this is the graduation level I'm doing. Mine. You try to take care of this. You will be overwhelmed to draw this Lewis structure. I'm telling you. Lone pair shall be memorized, right? This trick I'm trying to teach you. Is it clear, mine? Got it?
Okay.
Understood this thing clearly? Fine.
Yeah.
So what we are doing? We are now understanding that it will be expanding that octet. And there any lone pair of electron? No.
No.
Clear? Now over here. Now have you taken a screenshot? Take a screenshot quickly. Thank you. We done? Thank you.
Yeah.
Shall you take? See again.
That's it.
Take
No,
it.
no. Yeah.
Thank you so much. See, now we are going to the part of what? Bromine. Where is bromine? What will be the general electronic configuration? Can you guide me? Of bromine?
Group 7.
NH2, then NP how much? How much you left out of 7? Tell me.
The
2
two
electrons
two
minus 7
electrons.
electrons,
So
how much
5.
left? 5.
And
Is
that's
it clear?
empty.
What
Yeah,
is
and so
what is N? Mine? What is N?
4.
4. It will be
4 is
4s2,
45.
4p5. Is it clear? Fine. Understood.
Yeah.
4s2, 4p5. Did you get this thing? Fine. Got it. Understood that. Is it clear?
Yes.
Is it clear to you?
Yeah.
Fine. Understood this thing. So this is a very important part. See. Now, can you write down the electronic configuration of it? 4s2, 4p5 we got, right?
Yes.
4s, 4p, right? Now there's a 3D, sorry, 4D, which is vacant, right? Vacant. Isn't it? Did you get this thing?
Yeah.
It is 4s2, 4p5. Clear? Now, Mahin, tell me. For this, suppose you have given BrF5. How to know that there's a lone pair of electron? How? Mind, how many unpaired electrons does the fluorines need from this bromine? How many unpaired electrons? You know what
5.
I'm saying? 5. Yes, brilliant answer. See, brilliant brain of chemistry. 5 unpaired electrons is needed, isn't it? So how
Yeah.
many unpaired electrons you're having now?
1 only.
1. So how many total unpaired electrons you need? 5.
4 more. 5 total.
4 more. Brilliant answer. So we put it over here. We put this over here. Is it clear? Fine. Understood?
Yeah.
Did you get this thing? Fine. Now fluorine will be able to form the pairing. Is it clear? Done?
Yeah.
Understood this thing?
Mm.
Understood? Did
Yeah.
this electron pair had gone to the bonding?
Mm.
Was this electron pair there in the bonding?
No.
No. So it will be a lone pair. Is it clear? Got it?
Yeah.
Understood. What is the hybridization? P3.
4
Then tell me. D.
to
D.
4
2.
2.
D2. Is it clear? Got
Yeah.
it? Easy. I've taught you the hybridization of the highest standard. Forget about SP, SP3, SP2. You have done higher standards. Is it clear? Mine
So
understood that if you have given a molecule to draw, don't do like this. Otherwise, you have to memorize millions of molecules. How will you memorize? Tell
mm,
Mahin. Easy?
understood. Yeah.
Clear?
Yeah.
Makes sense? Thank you. Mahin, now go to this. Go to the periodic table. The normal periodic table. You write down the electronic configuration, outermost. Then you try to show it. Do it. Do it. 5s and 5p, isn't it? Now,
Yes.
wait.
Then it
Wait. Just wait. Now tell me that how many bonding electron unpairing xenon has to do? How
1
many
2.
unpaired electrons does it need in bonding? 4. Is it
Yeah.
clear?
Yeah.
So to unpair, how many unpaired electrons does it had now?
So
Fine.
like this.
Okay, I didn't see this. Please forgive me. Fluorine will be bonding like this, isn't it? Clear? Understood? What's the hybridization? Tell me.
Um.
P2, D2. Is it clear?
Yeah.
P2,
2.
D2. There are 2p and 2ds. How
Yeah.
many lone pairs of electrons are there? How many electron domains are there? Tell me.
There are 6
1,
electrons.
2, 3, 4, 5, 6, isn't it? 6 electron
Yeah.
domains, right? And how many lone pair of electron are there in 6 electron
2
domain?
total.
2 lone pairs. So 6 electron domain is what particular geometry? Tell me. What
Uh,
geometry?
it'll be
Octahedral, isn't it?
octahedral, which
Octahedral.
will
And
be
it
the
will be octahedral.
and the
And where
equatorial
did you keep the lone pair of electron in? Tell me.
equatorial positions.
Equatorial position. Is it clear? Got it?
Yeah.
Got it? Easy?
Yeah.
Easy. What will the structure? Planar.
Octet.
Square planar.
Sorry. Square planar. Okay.
Square planar. Is it clear?
Yeah.
Easy, Mahin? Easy? Fine.
Yes.
Now, remember one thing: if you're asked to draw the Lewis structures, always you have to add the electrons, isn't it? Which is minus agar hoga. If it's minus, you have to add electrons. Is it clear? If there's a minus, you have to add electrons. Is it clear? You
Yeah.
first draw the 5 starting the total number of valence electrons first, and then as per I've done that, you have to do like that. That's shortcut, isn't it? Did it help
Yeah.
you to do it easily? Did it help you to do it easily? Otherwise, you have
Yes.
to memorize, right? Isn't it? That how many electrons are there? Is it clear? Right?
Yes.
Now come to this part. Now, if you see when we talk about the hybridization, how to quickly find out the hybridization? Fine. Now write down. If there are 2 electron domains, it will be sp.
Yeah.
If there are 3 electron domains, it will be
SP.
sp2. If
Yeah.
there are 4 electron domain, it will be sp3. Is it clear? This. Can you understand how to do it
Yeah.
clearly? Now, in your exam, now you will be getting questions like this. Cruel questions like this. Is it clear? They'll be telling you that what is the hybridization around carbon, around nitrogen. But can you tell me what is the electron domain around this particular nitrogen? This is a trap question. I'm warning you. This is a common trap question because you're in IB, right? You have to know that. You have to know a very important thing that nitrogen has got how many electrons in the outermost orbit? Tell me.
Um,
5 electrons in the outermost orbit. I've given a big hint. Can you tell me that what is the electron domain of this? Ah, Mahin, very good, brilliant. Bless you.
okay.
This is the thing you have to do.
4
4
electron.
electron domain. What will the hybridization?
SP.
Wait. You don't have to do this. Directly tell me. 4 electron domain I told, na? Directly. sp3. That's all.
SP. Yeah.
Is it clear?
Yeah.
Fine.
Yes.
Understood. Now tell me what will be the hybridization around 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 the carbons? Tell me. Tell me.
Which carbon?
This carbon and this carbon. Tell me.
It will
Count
be
the electron domain first. Count it. Circle it. Circle it, mine. 1, 2, 3. So right, 3 electron domain. It was sp2. Straight away, simple. Is it clear?
4.
4 electron domain is sp3. Clear?
Yeah.
Understood this thing? Clear? Did you get this thing easily now? Absolutely clear? Fine.
Yes.
Now let's go
Yeah.
go to some past paper questions, right? And solve it. Come over here. Over here. Just 1 minute. You have to do this only, huh? You don't have to go to the hybridization drawing, I'm telling you, right? It won't come. Mahin, can you just tell me that, see, they're asking a question. That what is the hybridization around this carbon? Can you draw the structure quickly? Carbon has got 4 hands, huh? Count and draw it, right? That will be better. Always try to, if you have a carboxylic acid, draw like this. It'll be faster, right? Like this. CO as this. Anyways, what's the hybridization? What is the electron domain around this carbon?
1, 2, 3, 3, 4.
3 electron domain. What's the hybridization? sp2. Quick. That was quick. What is the hybridization around this carbon?
Um,
First, right, 4 electron domain. Therefore, sp3. Is it clear? Easy now.
Yeah.
Solved. Understood?
Yeah, sir.
Now we learned that in a sigma bond, it can be overlap between SS, it can be overlap between PP, it can be overlap between SP, and also hybrid orbitals are also. Is it clear? sp2s, sp3s, right? Isn't it? Whatever. SPS, right? Or sp2p, anything. But a pi bond will always be a overlap in between pure p orbitals. Is it clear? Got it? Now can you tell me the answer? Now, can you underline the most important word over here in this 44? Can you circle the important word over here? Tell me. Sigma. Now, tell me.
SP.
First one is completed as you saw, right? Then S and P. Tell me. Hydrogen and chlorine, right? Fine. S and P, isn't it? This is PP. Tell me. Fluorine. Got it?
So what does it mean end on?
End on means means along the internuclear axes,
Oh,
right?
okay.
Or sideways will be what? Sideways will be pi bond. Is it clear? Understood?
Yeah.
Clear, easy.
Okay.
Understood this thing? Got it? Suppose sp3s. Let's see. Now let's quickly find out what's the hybridization of this carbon
sp3.
sp3. What is this per orbital which is actually coming to overlap in hydrogen? 1s. So
1s.
sp3s. Is it clear? Easy.
Yes. Yeah, it's 3.
Understood? Clear? Got it?
Yeah.
Got it? Now see,
Okay.
suppose I'm coming to this answer. Now, what is the hybridization of this carbon? Tell me.
sp3.
sp. Count the number of electron domains.
sp2, sorry. No,
Don't hurry up. Don't hurry up. Don't hurry up. This is not a Kornberger it's sort of here round, buzzer round. Go slow. Please go slow. This is not a buzzer round, right? sp. Is it clear? So what is
Yeah.
the orbital over here of this hydrogen?
S.
S. So this will be sp and s overlap. Is it clear?
Yeah.
Got it? Is it clear? Fine.
Yes.
Got it. See sp2p. Can you give an example? See. What is this electron domain? Tell me. What is the orbital of this chlorine? Tell me. P. So it will be sp2p. Is it clear?
Yeah.
What is this this electron domain of this carbon? Write down mine. I told you to write down 3 electron domain. Then you write. I told you, na. 3 electron domain. Not
And then
domain
this
you have to write. 3ED. That's all. sp2. Now what is this? S.
S.
It will be sp and s. Is it clear? Got it?
Yeah.
Sorry, sp2 and s. Is it clear? This? Clear?
Yeah.
Understood? This bond, hydrogen. Is it clear now? Absolutely clear?
Yes.
Clear to you? Fine. Now we are going to what? We are going to the part. This was what? This was all about the hybridization difficult topics, right? Isn't it?